Welcome back to Know How Right Now. I'm going to solve a problem using Newton's second law. Okay, so suppose we know some skateboarder that skates. Let's draw our little skateboard here. Okay, and he goes from one point to another, and we take into account this point right here, which is our initial point, where the initial point of our system, and this point here. So this is the initial velocity, and here's our final velocity. So he starts skateboarding, he starts pedaling, and then he stops right here. But at this point, he's going some velocity. V naught is equal to 2.60 meters per second. And at the final velocity, he's at rest. So let's call this final velocity is equal to 0. Okay. Now we know his mass. His mass is 71 kilograms. And we know that at some time, actually, from here to here, it takes him 3.20 seconds. I don't know, make it interesting. 3.28 seconds. So he starts here with the velocity, he ends here with no velocity, or 0, his speed is 0. And it takes him 3.28 seconds to get to his velocity final, which is equal to 0. Okay, so now we know that he stops pedaling right here, and he basically starts slowing down. And we know that what has made him slow down is the force of friction. So now we have the force of friction, and we want to know what the force of friction is equal to. What's the force of friction? And what do we need to know? Well, if we use Newton's second law, that is, that net force is equal to mass times acceleration, then we can find out what friction is. But there's one other thing that we need to know, and that is what our acceleration is. And we can find that acceleration because we know at least 3 pieces of information so that we can use a kinematic equation. And in this case, we want to make it a simple one. We have this kinematic equation. Velocity final is equal to velocity naught plus acceleration times time. And we know that the final velocity is equal to 0. So now we can just solve for this a right here. Let's solve for that. And so let's subtract v naught from both sides. And then we'll divide t on both sides. So our acceleration is equal to negative v naught over t. Let's get another marker. So now we know that this is the acceleration. We can plug it in just like this. I've got v naught. I've got our time that it took, and so therefore, and we know that our acceleration is going to be negative because time can't be negative. So let's go ahead and plug in. We have 2.60 meters per second divided by time, which is 3.28 seconds. And I don't know exactly what that is, so I'm going to use my trusty calculator here. We have 2.60 divided by 3.28. So it's 0.792. And that is meters per second divided by seconds, so meters per second squared. So that's our acceleration. So I'm going to go ahead and put acceleration right here. Acceleration is equal to 0.792 meters per second squared. Now I'm going to go ahead and erase some of this here, because now we're just going to use Newton's law to find out what the force of friction is. But first, I want to stress the importance of drawing a free body diagram. Now, what's the free body diagram on this guy? He's going over, he's got a velocity, he's traveling to the right, and eventually he slows down. But we know for sure that we've got a force downwards called weight, but we also have an equal and opposite force called the normal force. These are equal, so they're equal and opposite, so we'll just forget about them. And we know that he's traveling in this direction, and it's important to say, okay, I want the direction, the positive x direction, to be positive. So this velocity right here to the right is positive. And you can do it negative, it doesn't matter. You can do negative, positive, but it's just important that you stay consistent. So if the velocity to the right is positive, then that means that the force of friction is slowing it down, so it must be going in the opposite direction. Let's call this the force of friction right here. Okay, it's also important to remember that these are all vectors, so when we take the net force, we're actually adding the sum of vectors, unlike scalars. And so we can't just add them, subtract them like a scalar number would be, but it has to be related to our system. And also an important thing is Newton's second law doesn't say that force is equal to mass times acceleration. He says that the net force is equal to mass times acceleration. And what he means is the net force of the system. So if it's not in the system, it doesn't take account for that. If it's just one force in the system, it doesn't take account for that unless that's the only force in the system or acting in that direction. So if we're looking at the net force in the y direction, then we're just looking for the vectors in the y direction, or the vectors in the x direction, or just, in this case, the general vectors, which in this case is just the force of friction. So, now, we said that the velocity is positive going that way, then that means that friction must be negative, so we're going to list it as negative. Negative friction is equal to mass times acceleration. Okay. Now, what are we trying to solve for? We're trying to solve for this friction right here. So I'm going to go ahead and divide a -1 on both sides. Friction is equal to negative mass times acceleration. And our acceleration, I think we might have said that it's negative. Let's think here. Yes, because remember we had negative velocity not is equal to, plus acceleration times time is equal to v final. And then we said v final is 0. And then we solved for a, which is, excuse me, here it is. Okay, so we have v naught plus a times t. So if we solve for a, then we get a is equal to negative v naught over t. So we know our acceleration is negative, so that's where I made my mistake. And that's important to us because it's going to affect our final answer. So we have force of friction is equal to mass times acceleration. Now, let's plug in numbers. We have the mass, and we also have the acceleration. And actually, this is going to be negative, because mass times acceleration times a negative number is just going to be a negative mass times acceleration. Now, what do we have here? Negative 71.0 kilograms times acceleration, which is negative 0.792 meters per second squared. And this is going to be our force of friction, which is equal to negative 56 newtons. So, if we want to know the vector of the force of friction, we can say that the force of friction is just negative, if we want to know the magnitude, it's just negative 56 newtons. But if we want to know it as a vector, if we want to know, in this case, we need to know the magnitude and we also need to know the direction. So it's negative 56 newtons. So 56 newtons is just the magnitude. But negative 56 says that it's actually, the friction is actually going in the opposite direction of this initial motion that the skateboarder is going. Okay? So this is your vector quantity right here. Okay? So don't forget that when you're taking your physics test or whatever, that if your professor asks for just the magnitude, it's just 56 newtons. But if he's asking for the vector quantity, then, or just the vector friction, so that means that the direction and the magnitude, then you want to make sure and include your negative sign. Or you can say 56 newtons in the negative x direction. Or you can say 56 newtons in the 56 newtons to the left. Alright, I hope that was helpful. If you have any questions, just post them. Thank you very much. Catch you later.